Hello, today I'd like to use this video, how the garbage collector works in Java, Python, and Go. It's made by Go. Yesterday and 4 days ago, I focused on listening and understanding the sentence meaning, the content's meaning. So today, I'd like to focus on pronunciation and speak out and listening. Okay, from the beginning, uh, maybe in the half, 2 minutes or 3 minutes, let's speak aloud and shadowing and overlapping. Let's dive right in. Mm, mm. Okay, so far, I try to read aloud from here. No, until here, around here. Okay, so sound off. Garbage collection makes programming in modern languages a lot easier. At its core, it's about reclaiming memory that At its core, it's about reclaiming memory that's no longer in use by a program. But why does it matter? Without effective memory management, programs can gradually eat up more and more memory, leading to slower performance, crashes, and outright failure. Today, we are Today, we are diving into what garbage collection is, and how it works in popular languages. At its heart, garbage collection revolves around a simple question: which objects in memory does program still use? This question is answered through the concept of reachability. Every program has GC root. These are starting point like global var These are starting points like variables and these are starting points like global variables and stack references. Any object that can be reached by following references from these roots is considered arrived and must be kept. Everything else is garbage, ready to be collected. To efficiently manage memory, garbage collectors typically implement a general, generational hierarchy. To efficiently manage to efficiently manage memory, garbage collectors typically implement a generational hierarchy. This design is based on the empire. This design is based on an empirical observation. This design is based on an empirical observation. This design is based on the empirical, 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 based on the empirical observation. Empirical observation. Most objects die young. Die young. Ah, die not in. Die young. Die young. Uh, empirical observation. Empirical observation and hierarchy. And most objects die young. Die young. In Java, in Java virtual machine, memory is divided into three main areas: the young generation, old generation, and metaspace. New objects start life in the young generation Eden state, Eden space, Eden space. If they survive multiple correction cycles, they graduate to cyberspace within the younger generation. The rare objects that persist even longer are promotion to the old generation, where correction happens less frequently, but more through so but more but more thoroughly, but more thoroughly, but more thoroughly, where correction happens less frequently, but more thoroughly. The metaspace is Java specific, the metaspace is Java specific, used for class metadata to help reduce memory footprint in large applications. うん。うん。reclaiming. Okay, one more time. Let's check pronounce. うん。うん。発音を丁寧に確認していきたい。Let me check pronunciation more seriously. Hi, ChatGPT. How can I say, how can I say, let me check the pronunciation more seriously. But uh, is it is this expression is correct? So I I would like to express more、丁寧にとか一つ一つしっかりみたいな意味合いで、え確認してっていう言葉を使いたい。 Makes sense. Carefree or thoroughly. So let me check the pronunciation more thoroughly or carefree. なんだろうな。なんだろうな。きめ細やかにってどういうニュアンス？meticulously か。meticulously ちょっと。Let's memo. え meticulously and carefree, thought-free. Thoroughly か。thoroughly. Go back to video. Garbage collection makes programming in modern languages a lot easier. At its core, it's about reclaiming, 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 reclaiming. At its core, it's about reclaiming memory that's no longer in use by a program. That's no longer At its core, it's about reclaiming memory that's no longer in use by program. By what does it matter? By what it, but why does it matter? But why does it matter? But why does it matter? By, but, but why does it matter? By, but why does it matter? But why does it matter? With the effective memory management, programs can gradually eat up, eat up, eat up more and more memory, leading to slower performance, crashes, and outright failure. Garbage collection makes programming in modern languages a lot easier. At its core, it's about reclaiming memory that's no longer in use by a program. But what does it matter? With the effective memory management, programs can gradually eat up more and more memory, leading to slower performance, crashes, and outright failure. Today, we dive Today we'll dive in Today we'll dive into what garbage collection is and how it works in popular language, how it works in popular languages. Ah, I forgot to start stopwatch. So, maybe it took 15 minutes, about 15 minutes so far. Is it right? 15 minutes. At its heart, at its heart, at its heart, and how it works popular languages. At its heart, language collection revolves around the simple question: which objects in memory does the program still use? This question is answered through the concept of reachability. Every program has GC roots to a starting point like global variables and check stack references. Any object that can be reached by following references from these roots is considered arrived and must be kept. Reachability. Every program has GC roots. These are starting points like global variables and stack references. Any object that can be reached by following references from these roots is considered arrived and must be kept. Every program has GC roots. This is a starting point like global, vari- global variables. This is a starting point like global variables and stack references. 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 How can I pronounce references? Ah, sorry. How can I pronounce references? References. Reference. No. How can I pronounce refer references? References. References. Like left, soft, refer, and references, 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 stack references. Any object that can, any object that, any object that can, any object that can be reached by following references, any object that can be reached by following references from hmm, any object that can be reached by following references from these routes. Any object that can be reached by sorry, any object that can be any object that can be reached by following references from these routes is considered alive and must be kept. Any object that can be reached by following references from these routes is considered alive and must be kept. Focus on rhythm, accent, pronounce. Hmm. Any object that can be reached by following references from these routes is considered alive and must be kept. From these routes is considered alive and must be kept. Any object that can be reached by following references from any object, any object, any object that can be reached by following references from these routes is considered alive and must be kept. Hmm. Any object that can be reached by following references from these routes is considered alive and must be kept. Any object that can be reached by following references mm, from these routes is considered alive mm, and must be kept. This reasonable. This reasonable. Rhythm. How can I say rhythm? No. Rhythm. 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 Everything else is garbage. Everything else is garbage. Anything else is garbage. Everything else is garbage. Mm, ready to be corrected. What's the difference between everything else is garbage and anything else is garbage? Hmm. So in this case, everything else is garbage means A, B, C. A is garbage, but B, C is not garbage. No, no. A is not specific garbage, but B, C is garbage. But anything else is garbage. There are A, B, C object. A is not garbage, but B, anything else. B, oh, it's garbage. C, oh, it's garbage. This is anything else, so each object is mm, garbage group. Everything else is A or everything else. But anything else is A or B, C. B, C. Mm. To efficiently manage memory, garbage collectors typically implement a generation hierarchy. To generational hierarchy. This design is based on empirical observation. Most objects most objects die young. In Japanese, memory is divided into three main areas: the young generation, old generation, and the meta space. New objects that arrive in the young generation's Eden space. If they survive multiple collection cycles, they graduate to the survivor space within the younger generation. The rare objects that persist even longer are promotion to the old generation, where collection happens less frequently, but more thoroughly. But the main space is Java-specific, used for just class metadata to help reduce memory footprint in large applications. Hmm. Okay, let's try without script. Garbage collection makes programming modern languages a lot easier. Its core about longer in use by a program. But why does it matter? With the effective management, programs in lack more and more memory. Slower performance crashes. Today, we are tackling garbage collection is how it works in popular languages. At its heart, garbage collection involves simple question. Which object memory is program induced? This question is so through the concept of reachability, every GC root, it's a starting point like Google variables stack references. Any object can be reached by following references, so these roots considered alive and must be kept. Everything else is garbage, ready to collect it. To efficiently manage memory, garbage collector typically implement a generational hierarchy. This design is based on empirical. Most objects die young. In Java virtual machine, memory is divided three main areas: the young generation, old generation, metaspace. New objects arrive at young generation Eden space. If this survives multiple collections and cycles, the graduated survival space is the young generation. The rare object is processed even longer at promotion or generation, where collection happens less frequently, the more slowly. Metaspace is Java-specific, useful cross metadata, happens met footprint and large applications. Mm, mm, in my feeling, mm, 60% I can understand, but with this speed, I can't understand listening, speaking, and understanding in parallel. Garbage collection makes programming modern languages a lot easier. Its core, it's about longer in use by program. By what? By if programs gradually even more and more memory. It crashes and oral failure. Today, we are tackling garbage collection is how it works in popular languages. At its heart, garbage collection involves works in popular languages. At its heart, garbage collection involves simple question: which object in memory to the programs in used? This question is answered through the concept of reachability. Every program has GC root. It's a starting point like global variables and stack references. Any object can be reached by following references. These roots is considered alive, must be kept. Anything else is ready. To efficiently manage memory, garbage collector typically implement generation hierarchy. This decides observation. Most object O. Time up. So, hmm, let's wrap up. Today's shadowing lesson is not enough for me because this content is a bit hard to understand. So I couldn't understand and speak aloud or shadowing in parallel. Mm. That's why, anyway, I would like to try one more time. Let me try one more time. Thank you for watching. So, see you later. Goodbye.